we'll review Unit 3. If you are unsure about some code from Unit 2, you will go to Piazza, look up Unit 2 videos and code, and once you found that, down here, it was posted a while ago, once you find there, down here is a link to the pirate file that you are welcome to use, make a copy of, and save it to your account. What's special about this file is that there are isFixed down here, isFixed, gender, isCat, and isYoung. Those four functions mentioned here are all defined. As an exercise in class, we went over how to make the isDog function, and you can see that in my code right over here. Notice the formatting is very similar to how isCat is defined, with one change where wherever you saw cat, you're replacing that with dog. So right here, right, is cat, cat becomes dog, and this is the key line that should make sense to you. You're now checking the species for whether or not it's equal to dog rather than whether or not things are equal to cat. And so as a reminder, we can run this code, and then over here, takes a little while for it to run. We can see that all our tests pass, great. We're interested in, I think, this one, and we see isDog, okay, it checked itself, false is false, passed and passed. Over here is the cat function, the cat isCat function checked animal A and animal B, and they all passed the tests. Let's go in here, and we can see, okay, animal A, are you actually a dog, or is this test making sense? See, Mittens is actually a cat, which is why the output should have been false. We checked to see that this side over here, the left-hand side, is dog, animal A, is Mittens, who is a cat. It's supposed to be false. Great. So then we can even type that in. Is dash dog, animal A, and then C. False. Great. And we can do the same for is dash dog, animal B. True. And then what is animal B? We see that it's Fritz, the dog. Notice these test cases are specific to my file. If you made your own code, your test cases and your animal A and animal B may be different from mine. So you may have a slightly different output. The next part, we have making datasets, subsets specifically. So imagine you have a bunch of, like a million people in your population, and you want to do the least amount of work in order to get a sense of the population. Here comes the idea of sampling. So if it were all in America, it would not be a good idea just to poll the Democrats if we're looking for the next president. It would not be okay to only survey young people, voters under 25, and it wouldn't be okay to call just churchgoers. That doesn't represent the whole population. And you'll see this later on in Unit 6, like more problems with sampling and what you should consider. So, in order to do so, to like pick samples in a more smart or clever way, we have this idea of filtering your data, especially at the beginning, where we don't know what the patterns are. We'll play around with our data, use Pirate as a tool to find interesting patterns. Okay, so that summarizes this thing. Logical pattern, logical subsets, those are subsets or parts, smaller samples of your data that you care about. So for the animal data set, maybe we're just interested in lizards, maybe we're just interested in the males, or the kittens in this example down here, which represent the young cats. This example here reminds you of how to use row column lookups, and also it reminds you, since you're looking for specific things, not only do you have to be a cat, kittens have to be young, so they're less than 2 years old. If you click on this thing, you'll be brought to the workbook. I think it starts at page 1. You'll look like this. You'll have to go down to page 14. Reminder to look at the bottom page number, 14 over here. So kittens, it's done for you already. Notice this function right here. It's R is the specific row. You look up the specific age number, looking to see that it's less than 2. And here comes the part that should look familiar. R square bracket species equals cat. So you look at the species column, columns go up and down to check whether it's equal to a cat, and it has to satisfy this. So if you're an old cat, like your age is 3, then you don't count as a kitten, even though you're a cat. And if you are, for example, a puppy, your age is like 1 year old, and you are a dog, notice it fails this part of this expression, this line of code. So that's how we get specifically these kittens. And for all these other examples that we'll soon explore, I'll pull up the answer key. We have all these things. Notice puppies, it's very similar to the kittens function, or checking over this. So you changed wherever it was cat to dog. Fixed is a function we already used before, so now we're being more specific. We're looking for fixed cats. So that part looks familiar. Since it's true and false already, no need to type in, for example, r square bracket fixed as a string. You don't. This is like extra to type in like that with this equal sign and true, because r fixed, for example, animal b fixed, it's already true or false. That's why you don't see that line of code there. But you can add it, it still functions the same. Now notice this one, it gets even more complicated, fixed kittens. So we use the kitten definition we had up here, and we tack on even more specific things. Are you also fixed? Notice it has two and keywords here. Dogs, wow, heavy dogs, so now we're looking at pounds. This should make sense. A more complicated one, heavy fixed dog, so this has to be true. Your weight must be greater than 50 pounds, and you have to be a dog. I think 1, 2, 3, 4, 5, 6. These first 6, most students, or some students didn't have problem with. It's this last one that threw you off. It uses a function we didn't play with that much. String contains. So this one you have to browse your table. Okay, this is the sheet protector thing I handed out. If we look here, there's string contains. So if you're looking for matches, you're working with strings specifically, you would use this. I think our example in Unit 1 was string contains, just to show you how it works. String contains, for example, pears, apples, and oranges. So that's the sentence you're looking at, and here's the specific word you want. For example, orange. That's true, because orange is a part of your list, and is a part of the string in argument 1, right there. But if you type in like milk, and milk is not a word that's in there, notice string contains gives you false. That's why you'll see over here, let's go back to page 14, down here you'll see string contains, the name has to contain s. Notice the row now, right, that row column lookup of the name is the first argument in the string contains function. And then you're looking for s, just that letter. And you have to be a cat. So we go back to our curriculum. We reviewed function is dog. We reviewed row column lookups. And now we're playing with ands and ors. So let's write some code. Down a little bit. Still working with the animals table. In my file, I'm down at line 90-ish over here. And now you can pretty much copy and paste these lines of code. Small sample and tiny sample. And it should work as we generate these tiny and small samples. So when we run our code, because anytime we make a change on the left-hand side, we must run for the computer to see it. And now, great. Now we can check. What do you get when you evaluate tiny sample? Tiny dash sample. So we're seeing what's inside. We see, it has 1, 2, 3 random animals. And then small sample, we type it in. Now we have a bit more. We have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 animals. What is the contract for random rows? What does the function do? Well, the contract seems, right, without looking at the sheet, we'll take a guess. Over here, the first argument, the first thing that you input, you have to put in a table. And then the second thing is how many rows you want. And so that looks like it's a number. Let's go here, pull up the reference sheet. Random rows. So And that's exactly what it tells here. T represents the table, that's the first argument. Then num rows, the number, for example, 3 and 8, that's how many rows we got. And the output here is a smaller table. So not just rows, it's usually a bunch of rows. All right, neat. So what? And now we know how to define values, so let's make subsets. We're using the functions we created from before, and now we're making random samples. So down here, we now have a variable named dogs and animal-table. We're applying the filter function, and notice the argument or the input here is the function name is dog. We can copy and paste these other lines, cats, fixed, and young, to just get those particular subsets. So this is going to represent all the things that are fixed, all the animals that are fixed. Down here, this row, 97, represents all the animals that are young. And let me type in cats, animal-table, filter is-cat. Okay, as we run our code, let's see what's there. So I'm shrinking this, and we're just going to interact. Animal table is unbound, okay? Unbound error typically means I likely typed something wrong. Animals table. Oops. Animals. Animals. Okay. Once more, let's see what happens. Okay, we passed our test, and now we want to see dogs. What are you? Okay, you are like 15 something rows of just dogs. If we click here to show, we see a dog, 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 dog being repeated. Let's see cats. Great, here are all the cats. Seems like there's about 11 of them. Fixed. Here are all the fixed animals. 18 of those about. And then these should be all the young animals. So now I see a combination of cats and dogs, and we see their age, it's less than 4. And there's 18 of those. Nice. So this starts the data representations, right? Okay, so we have these particular subsets, all the dogs, all the cats, all the fixed animals, all the young animals. Let's try this thing out next. Let's make some pie charts. Copy. We'll paste that in down here. Pie charts. Let's run. And let's see. So this is just species. We can now have a visualization of our species. So we have 2 rabbits, 2 lizards, 15 dogs, 1 tarantula, and 11 cats. Nice. What subsets do you think will give the most accurate approximations of the original chart? Let's see. Pie chart. If I'm unsure about how it works, we'll go back to our contracts reference sheet. We look at pie chart. Seems like it's on the second page over here. It has to be a column and a string. Cool. So there's our original based on species. And let's try inputting these other ones. So we can play with these in the interactions area. They are temporary, we don't need to save them unless we want to. Dogs, species. Let's take a look at that. Great, 100% dog. Nope, that doesn't match. Not a good idea. Let's try looking at all the cats. Cats. Nope, also no good. Now we'll look at all the fixed animals. Still focusing on their species. Now we're applying our data set. Oh, not bad. All right, there's dog, there's some cats, there's some rabbits. Nice. And now pie chart. Remember, I'm pressing the up key to save some time with typing. The up key allows the computer to repeat what you last entered. So let's see on young. Oh, that's pretty good. There's more of these lizards, right? But the shape of this pie chart looks a lot like my original species graph, so that's not bad either. And lastly, let's apply those tiny samples that was generated using the random rows function. Species. Nope, not good. We only got one dog, one rabbit, and one dog. And then we can try, alright, what about the small sample? The equal amount of dog and lizard. That doesn't look like our original data set. So I just compared all these charts, which one is most representative of the whole population. Why? Well, it has to be the is young. The chart represents all the young animals and the species based on whether or not they're fixed. All these other ones are not too good samples. It doesn't look like our original data. So if we scroll up a little bit, our original data was this one up here, right? Species plotted based on the entire table. It looks like this. Okay, this is all 31 animals. This is a subset, a smaller bunch of those animals graphed on species. They are the young ones and the fixed ones. Those are the subsets that are most representative of our whole animal population. And that's all. You should explore your own data set by creating pie charts, creating some interesting functions or contracts to see what you can find from there. Maybe in the cereals data set, you find the higher sugar content ones are what higher in calories, or over here, was it maybe like General Mills tends to make all the like unhealthy cereals versus Post makes all the healthy cereals. Who knows? Those are some interesting questions you can think about answering when you compare their manufacturer to fat or calories to determine some interesting patterns.